So now we have an idea as to what standard deviation somewhat represents, somewhat of that it's how wide or narrow a certain set of data is, or how close or how far apart that set of data is. Now, how do we solve for standard deviation, and what do those numbers mean? We're going to take a look at how do we solve for standard deviation. We're going to do it in two different ways. Number one, we're going to be taking a look at how do we do it by hand, step by step, one at a time. And number two, we're going to take a look at how can we use a little bit of technology to solve for it to make it a little bit quicker. Again, when we have a small group of data, we can do it by hand. When we have a large group of data, we'll have to do it using technology. So here's our equation for standard deviation. And I've tried to make it a little bit bigger here so we can get a better idea as to what it looks like. But to calculate our standard deviation, and standard deviation is going to have this little symbol here. This is a symbol called sigma. It looks kind of like a bit of a 6 or a 9, but it's tilted on its side, and it's something called sigma. It's a Greek letter. We use it. It's a term sigma. And how we solve that is we take the summation. Okay, so remember that this is the sum of. Okay, so it's sum of a whole bunch of different points. What we do is we take each data point. X is each of our data points. So in the case of our test scores, which we'll look at in just a little bit, each one of these 5 is a data point for class A. Each one of these 5 is a data point for class B. Okay? So each one of those are data points. We take every single data point and we subtract the mean from that data point. So we do x minus mean, and then we square that answer. And then we do the next one, x plus minus mean, square that answer. And every time after that, we do that, we take the sum of them all. We add all those together, then we divide by n. Okay, n is the number of data points that we have, and I have all those definitions here on the side as well. N is the number of data points that we have. So we divide by n, and we take the square root of our answer. That is the standard deviation. What that tells us is what is the average distance a point is away from the mean. Okay? It tells us the average distance a point is away from the mean. So what is the average? Is it really close? Is it going to be a small average, small number? Or is it going to be really far away, a big average? And so it'll be a really spread out set of data. So we're going to use this equation and we're going to solve for the standard deviation for, we're going to do class A. Okay, so I'm going to start with class A. Class B is one of your, might be one of the assignments. Trying to remember now if it's not one of the questions on the assignment, but we're going to solve for class A and we're going to do it here on this video. The first thing that we need to do is we need to find what is the mean. Okay, and so we're going to put in what is the mean. Now, the mean, we already solved for it earlier. And let's see if we can get it in here. So we're going to put in our mean, or mu, is equal to 69.4%. Okay, so this is what we solved for that earlier already. We did that prior, so that was something we did already. Now, what we're going to do is we're going to subtract the mean from each piece of data. So in here, we have each piece of data. I've written it out in a little chart, and we're going to subtract them. So we're going to start with that. And so we're going to do 67 minus 69.4, and that equals negative 2.4. And then we're going to do that again for 76. We're going to do 76 minus 69.4, and that is going to equal to 6.6. We do it here, so we're going to do this for every single value. And this is where it can become a little bit time consuming. And it's equals 0.4, 68. Again, you'll notice that minus 69.4. This, like I said, it becomes, sorry, this is a negative, and this one should be a negative as well. Doesn't make a huge difference later on, but it is math. So we need to make sure that we negative 2.4. All right, so I start off by subtracting each one. Now, the next thing that we're going to do is we're going to take the square of each value. So when we look at the equation that we had here, we subtract each one and then we square each one. So we subtract, square, and then we add all of them, all those squares together. So in this case here, we're going to square each of our answers. And so this is then negative 2.4 squared. Get out of there. Okay, and negative 2.4 squared is 5.76. I've done some of these calculations ahead of time so that just to try to go a little bit quicker. And so this one's going to be 6.6 squared is equal to 43.56. And the next one, negative 0.4 squared is equal to 0.16. And you'll notice now, like when we square a negative, it becomes, the answer is a positive. They're all going to be positives. So that's really nice. And that's actually the reason that we square it. It's to make them all positives, 1.96. And the last one, negative 2.4 squared is equal to 5.76. We had that one again. So sometimes we can like repeat. So you'll notice here now we've got each one of our values. So each one of our data points here, we subtract it from the mean, and then we subtract the mean, and then we come up with our, and then we square that answer. Now the next step that we do is we need to calculate the sum of all of these here. Okay, so we calculate the sum and we add all of them. So 5.76 plus 43.56 plus 0.16 and so on and so forth. This is just like when we're trying to find the mean. We add up all of our values and we're going to end up dividing by the number of values we have. And so if we add this all together, we get 57.2. And we get 57.2. So that's what happens when we add all of them together. There's our total. So what we have done right here is we've done this top part. We subtracted the mean from each data point, squared that value, and then we add them all together. The next thing we need to do is divide by n. So we've done some of that work now already. And so we're going to put into our next one here is, there we go, there's my function. And so sigma is equal to the square root of 57.2 divided by 5. Okay, so that's what we're doing there. We're doing 57.2 divided by 5. That was, again, that sum that we came up with, 57.2. We divide it by 5 because there is 5 values. Then, okay, so once we've finished, or once we divide, and again, I'm just going to try to put that in order here. So we got our square root of 11.44. So if we divide by 5, we get the square root of 11.44. And finally, we take the square root of that answer. And now again, I'm doing this without showing you the calculator. You can do the calculations yourself. 3.38. All right, so this is the value of the standard deviation. Okay, this is a value of the standard deviation, meaning that that is the average distance that something is away from the mean. And if you look at those you have like 2.4, 6.6, 0.4, 1.4, 2.4. Okay, that 6.6 kind of, skews that data a little bit, and that's where we get a little bit of a bigger one. Okay. Now, we're also going to take a look, and this will happen on the next page or on the next video. We're going to take a look at how we can do this digitally using some software. I'm going to be sending you the software, and I'll show you how to use it on another video. But we can use that software. It used to be Excel Miner. That's changed. I haven't adjusted the notes though yet, so apologies on that. But we're going to use software to solve, and when we do, again, we get the same answer or it's extremely close. I'm going to use the same answer. We know that sigma for class A is equal to 3.38. So for class A, it's 3.38. For B, the standard deviation, and I'm going to put that in there again, sigma is equal to 7.09. Okay, so we have these two different values. And again, we've gone through how to find standard deviation. We can do some more practice with that in a little bit, and there will be some on the assignment as well. But these are just our answers here. So these are the standard deviations for our two classes. Okay, so class A has a standard deviation of 3.38. Class B has a standard deviation of 7.09. What that means is that because B's is bigger, it means that that group has a wider range of averages. Okay, so they had a wider range of averages, meaning they're farther away from the mean. Okay, normally. Okay, they're normally farther away from the mean. It means that sometimes they'll do really bad, sometimes they'll do really good. Whereas A is much closer, so they'll be less far from the mean. They'll be very close. They'll kind of do roughly the same each time. Okay, or at least somewhat based on what we have here. So, which class has the lower standard deviation? Well, that's definitely class A. And what does this apply about the average marks? Okay, it means their average test marks are more consistent than class B. Okay, class B has a wider range. Class A is much more consistent with their average mark. Okay, each test had a very similar average mark, whereas class B had a very wide range of class marks.